Hello and welcome to the second part of Week 9 Lab for Basic Electricity. What we're doing on page 185, we're now constructing a circuit where both light bulbs, L1 and L2, are independently controlled by their own switches. So switch 1 is in series with L1, light bulb 1. Switch 2 is in series with light bulb 2. So both loads parallel to each other and independently controlled bulbs. So let's wire up this circuit. Remember to have your power switch turned off because these will become live as soon as this switch is turned on. So we want to make sure that it is off, the light is not on. We'll connect L1 to our circuit breaker. Again, it doesn't matter which side of the circuit breaker that we connect it to, but we have to have it in series with the circuit before we connect our two switches. In this case, we're going to power switch 1. Again, being a switch, it does not matter which terminal you connect to. A switch is just going to open the circuit, so it doesn't have a dedicated input or output in this example. We're going to connect switch 2 since this is a parallel path. So switch 2, we have L1 from our circuit breaker connecting to switch 2, and now we'll go to the respective light bulbs. From switch 1, connect to L1, connecting to the black terminal. From switch 2, we're going to connect to the black terminal of light bulb 2. From light bulb 1, to complete our circuit, connect the white terminal back to neutral. And we'll do the same thing for light bulb 2, connecting it back to neutral. As an alternate method, you could connect the circuit like this, but for simplicity, for you to better see the circuit, understand the circuit, I would recommend connecting back to our neutral terminal, considering this would be a home run shot as it's referred to. So now that we have our circuit connected, we're going to close switch 1. So thinking of closing switch 1, what load that will energize, we'll turn our main power on. Switch 1 will only turn on light bulb 1. Measured IT, so we're measuring the total circuit current. If we only have one light bulb on, the total current will only be that from light bulb 1. I'm going to turn switch 1 off, connect our meter properly. So we have to switch our lead from voltage and resistance to current. We have to change the meter position to AC amps. And now we can connect the meter within the circuit. I'm going to remove the neutral line from the circuit. I will disconnect it from the light bulb, plug it in up here at the neutral connection. That way we do not have this loose dangling where it might touch the board. Remember, you're working with 120 volts AC. Severe damage to the board or injury to yourself could result. We will turn switch 1 back on. We'll complete our path back to neutral and measure the current. In this example, we've got 0.526 amps. We'll round that to 0.52. I'll remove the meter from the circuit, record at step 2, 0.52 amps. Turning off switch 1, reconnecting the neutral to the bulb, turning switch 1 back on. Switch 1 is energized. To measure EL1 at step 3, we've got to remember to change the probe position connection. Switch our meter back to AC volts and measure EL1. 122.3 volts. So we've recorded our 0.52 amps for IT, which again is only measuring L1. We have not turned on switch 2, closed switch 2, so we're only measuring L1 current. We measured EL1. In this example, we had 122.3 volts. Next, we're going to measure EL2. EL2 is not illuminated, so we can make the assumption that there is no voltage applied. And there is not. So 0 volts at step 4. Measured IL1. We actually did that. I went a step ahead. I did not measure IT. I'm going to demonstrate that now to show you what the total current would be within the circuit. When I disconnected this wire, I was only measuring IL1. So let's go back, leaving this connected. We're going to disconnect, turn off our power. We're going to disconnect L1 to our circuit breaker. We will place the meter back in the current measurement mode. Turn our main power switch back on. You notice that the light bulb did not illuminate. We will measure from L1 to our circuit breaker, and you'll notice it's approximately the same. 0.526 was our current before. It is 0.530 now. That is IT. That is IT. To give you an example, if I momentarily turn on switch 2, you see the current increase to 1.058. Switch 2 turned off, de-energizes light bulb 2. Our current is back to 0.529. So that is something to make note of. Again, in this step, since we were only closing switch 1, we knew that IT was only L1, L1 current, but this would be the proper connection to measure IT. Turn our power off. We're now to measure IL1 and IL2 individually. We will remove the meter from the circuit, reconnect L1 to the circuit breaker, reapply power. In these steps, switch 1 is the only switch that is closed. Switch 2 has not been closed. So as you're measuring in step 5, that is IL1. Step 6 is IL2. We have not closed switch 2. So let's see what our current would be at step 6 after measuring step 5. As I did before, I can remove the neutral, place it back, plug it back into itself at the neutral power connection. And now this is measuring IL1, 0.526 amps. We will round that off to 0.52. Record that information. Step 6 is measuring IL2. We will reconnect. L1, disconnect. L2, measure the current, and we find we have 0 amps, which we should, since we have not completed the path of closing switch 2. In step 7, we're going to calculate our power for L1. So that requires us to take our voltage measurement, 122.3 in this example, times 0.52 amps. .3 times 0.52, and that gives us 63.59 watts, or 63.6 watts, rounding up. The calculated PL2 in step 8, if we have 0 amps measured IL2, 0 times 122.2, 0 volts. We had 0 volts at EL2, 0 volt amps IL2, so 0 watts is our power at step 8. Our calculated total is 63.6. PL1 measured, calculated 63.6 watts. PL2 was 0 watts. So 63.6 plus 0 watts equals 63.6 watts. All of these values are approximate for this particular exercise. Your measurements will be different. Step 10, we open switch 1, so turning that off. Step 11, closing switch 2. We have to reconnect our neutral for it to energize. There, we've powered L2. Step 12 is measuring IT. So we will turn off the main power switch, remove the wire from the L1 to the circuit breaker, place our meter, make sure that your probe connection is correct for current, as well as the setting to AC amps. We will complete the path with the meter from L1 to the circuit breaker and turn our main AC switch back on, and record at step 12 our total current, which is 0.535. We can round that to 0.53. Our measured EL1 voltage, you can measure that. However, if the switch 1 is off, the bulb is not illuminated, we would make the assumption there would be 0 volts here. Let's go ahead and measure that to be sure that the bulb is not burned out. A bulb that is burned out will have voltage applied, but the bulb not illuminate because the filament is open. We've got to place our meter back to the voltage position for the probe connection. Set the meter back to voltage. Can't stress enough that you always have to verify that you've removed from the amp measurement and placed it to the voltage resistance measurement, and place the meter in the voltage measurement position as well when you're placing the probes in parallel with a load. So our measured EL1 at step 13 is 0 volts. So we do not have voltage applied to light bulb 1. Step 14 is measuring the voltage at EL2. Place the probes parallel to the load. We have 122.4 volts measured. We'll record that. In step 15, we're measuring IL1 and IL2. Again, if we did not have voltage at